All right, welcome to a video lesson on solving systems of linear and quadratic equations. So since you have solved systems in previous math courses, you already know that the following is true. A solution is an ordered pair that satisfies both equations. So I'm going to be looking for an answer in the form of an ordered pair today. So I'm going to teach you graphically first, and I'll teach you algebraically second using substitution. So graphically speaking, I want to figure out the system of these two equations. The first one is linear, the second one is quadratic, okay? The solution is where the two equations are intersecting. The two graphs are crossing. So the green line touches the blue line right here, which is at a 0 and then a -2. So one answer is 0, -2. My other answer would be a 1, 2, 3, 4, 1, 2. 4, 2. So those are your two answers. So again, I'm going to have an order pair for a system of equation. Now, if you didn't have a calculator, you could do that algebraically. So to do that, you're going to set them equal. So they're both equal to y, therefore they are equal to themselves. So I would have x squared minus 3x minus 2 and set it equal to x minus 2. Now to do this algebraically, I'm either going to factor or use the quadratic formula. So first you need to make sure it is equal to 0 by subtracting x under its like term and then adding 2 under its like term. Okay, so this is an imaginary one here, so I'd have x squared minus 4x, and then that ends up canceling out. So I only have two terms equal to 0. Okay, if it is two terms, I know the quickest way is to factor and take out a greatest common factor. So what they have in common, they have an x in common. Do your parentheses. If I take an x away, I'm left with an x and then minus a 4. To solve this, I'm going to set them both equal to 0. And so one answer is x equals 0. The other answer, I'm going to switch my sign, add 4 to both sides to get x equals a positive 4. Okay, now this looks similar to your order pair. It's your x values. Okay, so one answer I know is 0 something. The other answer I know is 4 something, because these are your x values. They're the first part of your order pair. To figure out the y value, you're going to plug it in to the easiest equation. So plug in to the easiest equation. In my opinion, it's always going to be the linear one, because it's less x's, less squareds. So I'm going to take y equals, I'm going to put a 0 in, x, or 0 minus 2. 0 minus 2 is -2, so that is your y part of your 0 order pair, which is what we already found. Same thing, I'm going to plug in 4 to my easiest equation. So I would have y equals 4 minus 2. 4 minus 2 is 2. So my second order pair is 4, 2. Okay? So again, you could graph it and look at the intersection, which is your two order pairs, or you can set them equal, get everything to one side, factor, and plug it into the easiest equation. I spelled equation wrong. Woo! Okay, so here's one example. Let's do some more. All right, we got another graph. I've got a linear and a quadratic. So again, the solution is where it is crossing. Crosses right here and right here. So this order pair would be a -1 and then a positive 3. This answer would be a 3, -5. Okay, so that's our solution. As long as you have a graph, it is not bad at all. Let's do this algebraically though. So I'm going to write the first one first. -2x plus 1, set it equal to a -x squared plus a 4. Okay, order doesn't matter. you can have them written backwards. So I need to move everything to one side. Since I want my x squared to be positive, I'm actually going to bring it over here. So I'm going to add x squared to both sides. Cancel. I cannot add x squared to either of these terms, so I'm going to write it in order. X squared first, minus 2x plus 1 equals a 4. Again, you can make it equal 0, minus 4. So I've got x squared minus 2x minus 3 equal to 0. Now, when I look at this problem, I know I have 3 terms, and my first term has no number, so I know this is an easier T-chart problem. So let me go ahead and jump to the T-chart. So I'm going to figure out what multiplies to get a negative 3 that will add to get a negative 2. 3 times 1 is the only thing that will multiply to get you to a negative 3. And then if you make it a negative 3 plus a 1, that will add to get a negative 2. So since my leading coefficient is a 1, there is no number in front, I can immediately jump to my parentheses, x minus 3, x plus 1. My last step, again, is to set them equal to 0. So I know by switching the signs, x is equal to a 3, and x is equal to a negative 1. So again, that checks out. We found that from our graph. So I know one answer is a 3 comma something, and my other answer is a negative 1 comma something. To figure out your y values, plug it into the easiest equation. Okay, so in my opinion, the linear one is easier. So I'm going to plug in a 3 for your x. So I would have negative 2 times 3 plus 1. Negative 2 times 3 is negative 6 plus 1, which is a negative 5, which, hey, we already found that. That checks out. Also plug in a negative 1. So negative 2 times negative 1 plus 1 will be a positive 2 plus 1, which is a 3. Hey, we already found that out. Okay, so if you're asking me why are we having to do all this work, if I have a graph, you won't always have a graph. That's why. Okay, so again, this one was a nice T-chart example. The first one was a nice greatest common factor example. So let's do one more of a quadratic formula example. All right, this one looks like it is crossing once. This one's a little harder to see. To me, that is where it's crossing at a negative 1, positive 2. So this one only has one solution. All right, so let's solve it algebraically now. I'm going to start with 2x squared equals negative 4x minus 2. I need to move these two to the left side. I'm going to do it very quick without showing any work by just changing the sign. So I'm going to have 2x squared plus 4x plus a 2. Because if you move it to the other side, you're doing the opposite operation. All right, now this one has a number in front. If I do the T-chart, it's going to be a whole lot of work. So let's jump straight into the quadratic formula. So I'm going to have x equals negative b, so negative 4, plus or minus the square root, b squared minus 4ac divided by 2a. All right, so let's do some mental math. Negative 4 out front, plus or minus square root. The denominator will be a 2 times 2, which is a 4. So now I just need to type in what is underneath the radical into the calculator. So I would do parentheses 4 squared minus 4 times 2 times 2. That gives me a 0. Okay? So under the parenthesis, or under the square root, I have a 0. The square root of 0 is just 0. So this is negative 4 plus or minus nothing over 4. I don't really need the nothing, so negative 4 divided by 4 is negative 1. So that is why I only have one answer to this problem. So I know, oops, negative 1 is your answer. Again, to figure out your y value, plug it into any equation you think is easier. So maybe we think this one's easier because it's shorter. So I would have 2 times negative 1 squared. Negative 1 squared is negative 1 times negative 1, which is a positive 1. 2 times 1 is 2. And then so my answer is going to be a negative 1, comma, a2. Which again is what we found from our graph. But if you do not have a graph, you must solve it algebraically. You can choose one of the 3 ways. You can do t-charts, you can do quadratic formula, or you can take out a greatest common factor. Now, if you have a calculator, I will teach you how to do it in there. Okay? So your calculator might not have perfect numbers like this graph. Okay? But I have 2 equations and I need to graph them using technology. Okay? So let's go to our calculator and I'm going to graph these in y equals. Important step if you thought everything I just did was way too much. So go to y equals. Type in the first one, x minus 1. Type in the second one, 3x squared minus 5. Look at the graph. So an answer I have would be right here, and an answer would be right here. But honestly, it's looking like a decimal. Okay? So the calculator buttons you're going to press, second, trace, and then I want to know the intersection. So second, trace, intersect. Let's write that down. I'm going to press second, trace, intersect. So this will always work if you don't want to do a lot of math. So it's going to ask you 3 questions. First curve, question mark. Get really close. Notice this is tracking on the linear line. So anywhere to the left or to the right of that, just get really close to it. Hit enter. It will then pop up to your second curve, which is my quadratic. Just get real close, hit enter, guess, hit enter one more time. Boom, there is your answer. Just write that as an order pair, -1, comma, -2. So one answer is -1, comma, -2. To find the other one, I'm just going to go hit the same buttons again. So second, trace. I'm going to find the intersection. But this time I want to put a blinky dot using the right arrow closer to this one. So get close to it, hit enter. The blinky dot will bounce to the other one. Just get close to it and hit enter, and then hit enter one last time. Boom, there is our answer. -1.3 repeating, and then 0.3 repeating. Okay? If you do not know what fraction that is, 1.3 repeating is 4/3. And then 0.3 repeating is 1/3. So if you wanted to put 1.3 repeating, that would be fine. 0.3 repeating. Or you can leave it as a fraction. So that is how you use technology to find the intersection of your line in quadratic. Okay? For time's sake, I'm not going to solve it algebraically because I just taught you a cool calculator trick. So you could use this calculator trick on anything. Okay? So just make sure you graph them, second, trace, and you are finding the intersection. Okay? Thank you for watching video on systems of linear and quadratics. You may now practice. I only gave you 5 problems, so try not to use the calculator for all of them. Try to get some review of the quadratic formula and all that. But do as many as you need to get better at this skill. Thank you for watching.